joined us today. Thank you so much. And thank you for joining us on this rather cold evening. Okay, so we're GKSS, and we're under the organization Geek Culture, which seeks to sort of shed light on the tech ecosystem, and that also incorporates uplifting and encouraging innovation within university environments to nurture tech talent and to build career-ready pipelines for students. Okay, so today I just have a short presentation regarding what we do, our team for meet and greet, as well as some resources that I've attached, which I will also put in either the chat or I'll follow up in email to those who've RSVP'd via the link. Okay, can I proceed?
Yes.
Thank you. Okay, so these are our team members. Okay, it's just 6 of us. I'm Mobile, just the bottom over here. Okay, this is our UNISA leadership team, and we're part of your student society body for this year. Okay, so part of the resource packs that we have is actually what helps us to also ensure that we're nurturing and developing student talent. If there's anyone else, may you please kindly mute your mic. Okay, thank you. Okay, so one resource.
Sorry, guys.
Okay, so one resource that we have here is from Miss Andrea Griffith, who's the Senior Developer Advocate at GitHub. And so this package and this link over here is simply a URL for your GitHub Student Developer Pack. Okay, so you have a number of resources that you can just follow up on to enhance your learning and to build your portfolio, right? So you have free Copilot, free GitHub Pro, as well as CompTIA exam vouchers. Just to reiterate, to those who've RSVP'd, I'll just follow up and send through these resources via email. Okay, we also have a link to a personalized newsletter, which also is targeted at building your understanding of tech fundamentals, as well as the collaborative side of your technical proficiency. Okay, so that would be the subscribe button over there. Okay, and that just needs to load. And then lastly, we also have a summation of these resources. As I previously said, I'll just send those through via mail. And if you have any questions to be directed directly to Ms. Andrea Griffith, you can just follow up to the link below with he11.dev. Okay, that's just it from our side. We're really excited to launch this collaboration and initiative with HackerRank. Yeah, so over to that team. Okay, thank you. Okay, in the meantime, let me just attach the said links in the chat.
Good evening, everyone. Can you please confirm for me that I'm audible and you can see my screen?
Yes, we can hear you and we can see.
Great. So my name is Patience Nawuza and I'm part of the HackerRank Campus Crew here at UNISA. And today we are excited to introduce to you something that can genuinely change your trajectory in tech, the HackerRank, and also give you insight on how to sharpen your problem-solving skills in the real-world high-pressure environment. So who we are a team of student leaders passionate about building a strong coding culture at UNISA. Each of us come from mathematics, applied mathematics, or computer science background, and we are deeply interested in using tech to solve real-world problems. Our mission is simple: to help students like you become confident, skilled, and competitive in the tech space. So why this session? A lot of us can solve problems when we are comfortable, when we have time, when there's no pressure. But the reality is the industry doesn't work like that. Interviews, assessments, and real-world problem solving require speed, clarity, and precision under pressure. So this session is about bridging that gap, helping you move from I understand to I can perform. So what exactly is HackerRank? HackerRank is one of the world's largest coding platforms with over 20 million users globally. It's not just for practice, it's an industry standard platform used by top companies to access talent. You can solve challenges in multiple programming languages like Python, Java, C++, and JavaScript. And the problems aren't random. They cover areas like data structures, algorithms, SQL, artificial intelligence, and machine learning. In simple terms, this is where you train like the real game. So you might ask yourself, what makes hackering powerful? Okay, so what makes hackering powerful is that it prepares you for the real world scenarios. You are not just coding, you are thinking critically, optimizing solutions, and learning how to perform under constraints. It's the most effective ways to build problem solving skills, prepare you for technical interviews, and stand out in a competitive job market. Now, to take things even further, we have someone who actively applies these principles, someone who understands both the theory and the practical side of problem solving. Our guest speaker today is Smangam Kunu, a student in applied mathematics and computer science. Um, so please join me in welcoming Smangam Kunu.
Hi, everyone. I hope I'm clear. Can you hear me?
Yes.
Yes, we can hear you.
We can hear you.
Thank you. As patient said, Smanga. Okay, I'll try to walk us through how do we solve these problems. Okay, firstly, we have our site, which is HackerRank UNISA. I'm gonna drop the link in the chat so that you can go together where it's possible. But if not, then you can just go through. Our site is Code, Compete, and Conquer. So this is your chance in order to learn how do we go about. We're on round 5, where we're doing interview prep, understanding how do we solve the problem. So we're gonna go. If we wanna solve any, we can either go here, go here, choose any challenges that you want to happen, then choose any question that you want. We're gonna do this one today, the change problem. But let's go down. And then here, once you solve the problem, then you put your name, student number, and then you choose whatever problem that you selected that you want to solve, and then you submit your approach. How many times tricky, but it can be optional, but I think it would be better to understand your approach. This also, if you write it down, it helps you with understanding, and it helps someone who's on the other side that, okay, this person understand what he or she was doing. So let's go get to near. If you click on it, it will take you to HackerRank officially website, and then to go here. And then from here, this is our problem. Usually when we attempt the problem, when we face with a problem, one needs to understand firstly, how do we solve the problem? In order to solve a problem, I think there's a book, not necessarily mathematics books, but a book that's help guide you how to, is written how to solve it. It's by George Powler. In order to solve a problem, understand what the problem is, and then from there you break it down. You break it down step by step, and then you solve that step by step until you eventually solve it all. So when you face with these kind of challenges or problem in that, because usually they produce this kind of problem in interviews, technical interviews. So you need to understand what is the problem about, and then how do you then go about solving it. So in order to solve this kind of problem, understand the data structure, your data type. You can choose either any problem, any language that you want to use. I'm comfortable with Python, but if someone else can use Bash, C, C+, or C#, I don't know what is the, Fortran, Go, Groove, Haskell, etc. And then from there, you are given a statement, right? This is the problem. Given an amount of denomination of coins, when you read the statement, you check, okay, there's some weights that are giveaway, like these ones, coins, and then also these denominations. These are giveaway. That's okay. Will help you pick a little bit what is this problem is about. Who do I looking for? And then this one, determine how many ways change can be made for an amount. There is a limitless supply of coins of each coin type. So here we need to we have an amount which is n, and then a list of coin dominations. And then the question is, how many different ways can you make this amount? And the important details, you have an unlimited coins, and then order does not matter. Okay, I think also there's what called, is it TL? TL. Sometimes it's better to write it down. Where's my network? My network is not make sure. Okay. We have an amount which we're looking for, which is n, and then the coin we can give a variable which is, can say C. Okay, for example, we are giving, let's say an amount is 4, and then the coin would be 3. So we're looking for a combination. Beerman, there's a little bit of this thing that can confuse us. There's something called permutation in mathematics, and there's something called combination. Combination, the order does not matter. Permutation, the order matter. 1 plus 2 and 2 plus 1. It does matter in permutation, but on combination, it does not matter. So it's one and the same thing. They both give us 3. So either we start with 2 or 1, it doesn't matter. So here we're looking for the combination. So you see, okay, how many different ways can you make this amount? So the amount is 4, and then we're giving from 1 to 4. So we have 1. So, from 1 to 3. So from here, how many times can we make out 4 amount with these numbers? So you can say 1. This will give us 4. So if this first cardinality, and then we have 1, This also gives us 4. And then we have what others? I think 2 plus 2. Just give us 4. And then we have 1 plus 3, I believe. And this was given. So yeah, this give us 4 ways. It's 4 ways in order to make the amount. So we realize here it's not about the minimum counts, but it's about counting the combination of them. So this is our answer. And then okay, we realize okay, this problem, what does this problem is all about? Here we're given 3 ways to make change for n. In 3 ways, you can have 1, 2, 3, and then we have 1, 2, 4, and then we have 3. And then we're given the description of the challenges that we need to solve. Complete the gateway. This is the functions that we're given. We need to write code under here. So gateway has the following parameters. Parameters are this variable within the head of the functions. We have an integer, which is n, the amount to make change for, and then we have integer which is c of m, the available const. This can be a loop. The available const dominations. What we need to return as an integer is the number of ways to make change. What is good about HackerRank is that it technically solves the problem with you. If we have been practicing too much, you realize, okay, here I've been given the information. The first line counts are 2 space separated integers n and m, where n is the amount of change, m is the number of change of count type. And then the second line contains m space separated integers that describe the value of each count type. And then constraints are what guide us. So are the rules, the limits that we cannot break, because if we break, then our code will fail. So C of I, it must be less than or equal to 50 or less than or greater or equal to 1. And then N must be less than or equal to 250 or greater or equal to 1. And then M must be less than or equal to 50 or greater than or equal to 1. Each of I is a guarantee to be texted, but it must be different. And then, so we're giving a hint here. How do we solve this? Solve the overlapping sub-problems. Remember we talked about that if you want to solve a problem, you must look on its subs. So you go step by step on this. So we're looking at subs, and then here we use an algorithm called dynamic programming. One may ask, what is dynamic programming? Dynamic programming is a method for solving the problems by breaking them into smaller overlapping sub-problems. Solving each sub-problems once and storing the results so you don't recompute them. So it helps you optimize your problem. It helps you optimize so that your problem can be fast. But one may say, okay, we got other way to solve this problem. You can also solve this problem using recursively, but there's some tests that you will not pass. Why? Because recursive takes time. So recursive it's when you call. It's when you go back and call your functions. So it go back and recall. This takes amount of time. It costs. I think I'll try to explain it later when we talk about time complexity, where it takes a lot of time in order to calculate. So and then this ended up your time limit, exceeding your time limit TLE, and then your code will fail. How do we solve? Think of a way to store and reference previously computed solution to avoid solving the same problem multiple times. Consider the degenerate cases. How many ways can you make changes from 0 cents? How many ways can you make changes for which are greater than 0 cents if you have no coins? If you are having, if you're having trouble defining your solutions though, then think about in terms of the base cases. Base cases is when base cases in some sense it's what guided or what stop us so that we're not gonna go either in infinite loop, or what is a simple answer. We know if, for example, if we're doing a infinite, a factorial, calculating a factorial number, no, okay. Factorial of 5 is 120. But in order, if you're trying to solve that using a Python, using a Python, so you know, okay, factorial of 5 is 120. So how do you define factorial of 5? You say 5 times 4 times 3 times 2 times 1. But a computer can go to 0. But a computer can go to 0, which is a red flag. Because if it goes to 0, this all becomes a 0. So you need to guide it so that it might not go here. So usually we say if n is equal to 1, and then return the answer. It means you have reached your base. So it's gonna go here 1 times 2, which is 2 times 3, 6 times 4 will be 20. 24 times 5 will be 120. If you are doing a factorial of 5. So that's what a dynamic and a base case help us in order to solve. Therefore, and then we need to see how do we solve our problem. Then we go here. You need to define a number of ways of making the count. So let's say dp creates an empty. Here we're creating a number of ways to make the count with the size n plus, so that we can store from 0 to n. For now, let's say n is 5. So this, why did I call it? This will create your zeros. Say n is 5. So we'll have we create a space to store our things. So we have zeros. 124. So n is 5. We have 0 zeros. We have created where to put the space. And then from there, we talk about a base case. Yes. So we just to show you there is a one way to make amount 0, and then you use a 0 cons. So we assign to 1. We assign it to 1. So if it's above 0, and then that won't work. And then we need now to process this space of what we have created, so to go through them. We process 1 con at a time. It is to ensure that we can't duplicate like 1 plus 2 and 2 plus 1, because this is a combination. This is not a permutation. this is not a promulgation problem. So we say we use a for loop, con in C. It's for loop. And then I think you need to, and then you need to start from the con, and then to make sure a small amount with the con. So I think we should get this amount in range. This is a built-in. And then we need to check ways to make amount, where to make ways to make, so coin minus the amount. If you can make amount, if you can minus a coin to amount, then you're adding this coin to give away. So we P amount. TP minus con. This plus is same as this plus equal to is same as adding this one. This means you adding this, you say TP is equal to TP of amount is equal to TP of amount plus TP of amount minus con. And this should then TP of n. And then you then return. There are ways of way to make our result counted, or how many counter we need to run to return. I think this should work unless there was some error. Okay, and then it went through. We go to, and then because these are kind of what interview. So your interviewer will need, you will the way you engage with your code, you as well explaining to them, so that they see that you understand what you're working on. And then so they will need to understand, why did you use this, understand your time and space complexity. One may answer, what is time and space complexity? Your time is how much for every input your code count. It doesn't matter. It doesn't matter how big your system or your computer you're running on your code. It's only particularly how much you input. That's how much your code will count. So if I have five elements that I need to put or list, for every input I put, it count this the number of time waiting. So that's your time complexity. So we have time complexity with we have big O of n, which is linear, and then we have big O of 1, which is constant. A linear, this is how it done. So each time you add something, it grows as you add something. And then you have big O of constants. I mean, big O of 1 it stays the same every time it's just adding. And then you have a big O of n squared, quadratic sign. A big O of logarithmic time, big O of n. I think there's also a big O of exponential, 2 of n, big O of 2 of n, etc. So this way you count your code, how does it affect your code? So this solution uses the dynamic programming, where your DP of I stores the number of ways to make the amount I. Therefore, we iterate, or we loop through each con and update all reachable amount from the con to n. And then for the term complexity, we have two nested loop, one over all cons, and then one over all amount up to n. So this will be peak of c times n, because we're looping from the nested loop from the con, so it's the peak of c times n. We're looping through the coins. This is our coin, and then this amount of n. So we have a peak of n. And then for spacey, we maintain a single array of size n plus 1. We just adding 1 from the n size. If it's 5, so you see a size of n, you have to give us 6. So this is a linear, which is peak of n. I think that's where we will be is or myself. We can then engage or ask any question that will like us to do. Over to you, and Will. Thank you very much for your time. Oh, okay. Let me submit the code. Sorry about that. Let me. Solution. Okay, we have solution, and then we copy this link. Then we go down. So good. And then student number. Challenge dynamic. And then that's where I drop the link. How many times did it take me? Say 23. We use dynamic programming efficiency. Audio efficiency. Maybe efficiency. We get peak of some complexity in space. And then we submit. And then we got the point. The bot, the leaderboard is updating. Yeah. So we just will check, okay, who's leading when. In most interview, that's what people will need. We need to understand. You understand your data structure. Your data structure are your binary search, your linked list, your prefix algorithm with dynamic programming, algorithms, and many. So once, every time you explain, you engage with your code, you also need to ask the interviewer, okay, as I was explaining, okay, they say giving amount and the domination of the cons. You can ask, even a silly question, you can ask, do we have the coin negative cons where someone owes? And then interviewer will tell you, okay, no or yes. So that will, because the interviewer needs to also understand that I am engaging with someone who's willing to learn. I'm engaging with someone who's open to engage with their seniors when they're working. Okay, you say, okay, we have a list, we have a list here. Is the list infinity? Yes, we were told that list is infinite. Just to confirm from the interviewer, so that we will bring an interviewer to focus on what you're trying to solve. So I think this is one of the things. Thank you very much. Over to you, the patient and Mobile.
Okay, thank you, Smanga. Thank you. That was really like insightful. Thank you for taking the time with that. I just wanted to reiterate a question that I had put in the comments. So in submitting the code, right, does the platform allow for peer review of alternate solutions? So to see other ways in which solutions can be approached. Yeah, and I really love like the detailed guidelines of the problem as well.
Yes, thank you. Because we get the solution from what you have submitted, and then from the backend we can get your comment, and then we can either send you an email if you would like us to show you the alternative solution.
Okay.
Okay,
Okay, that's cool.
and then for Pumlane, yes, it does have a different choice. Even on an interview, let me share screen. Even in an interview, when you have the platform, because usually they use the same platform. Last time we're having a hackathon, so we use the same thing. I hope you can see my screen. So this is, you can choose any language that you feel comfortable with. If it's JavaScript or Swift, Smalltalk, or Scalar, your Rust, Ruby, R, I wonder who's using R, etc. Your Bash, C. So you may choose any language that you feel comfortable with. And also one of the tips that you need when you're going to this search, because we're obviously gonna be scared and then uzosaba. So you need to practice a particular language that you will feel comfortable to use, even if maybe you don't necessarily understand the problem. But if you are comfortable with that language, you can just play around, try to look, okay, how do I go about this? Okay, I know that Python does this, it limits its strength and its weakness. So you can easily, even if maybe somehow you lost on problem statement, and also with the problem statement, you can ask the interviewer, okay, I don't understand this and this. The interviewer will much more easily to engage with you because you seem like someone who's willing to learn.
Okay. Okay, thank you. Thank you for that. I just wanted to ask also, with I think in the beginning you had differentiated between challenges and competitions. How does that work? And in the context of like hackathon preparation, which would you advise students push for?
I think challenges, I would say, challenges are something that we do in a freely, not closed environment where we need to finish fast.
Okay.
And then a competition like a hackathon is something that's a time limit. So you need to finish here and now. How do you then approach it? I think most of the time one must always be willingly to learn.
That's good.
When you go to the challenges or to the hackathon, don't go there because say I want to get money or I want to get be recognized. Go there and because you want to solve a particular problem. If you go there because you want to get money, you get hurt if you don't get it. But if you go there because you want to solve a particular problem, actually we had a hackathon in IBM in 2024. In South Africa, we have a problem of load shedding. Luckily, we won. But what mostly made us be unique to other team or to other members, I would say to the judges that we were experiencing a real problem that we wanted to solve through the data, not because we feel passionate about it. Yes, we have that passion, but also be guided by the data sets. If you are maybe say you're using Dataton or even a simple hackathon, because don't be swinged by the emotions or mood. But what does the data says in that particular problem? Do your research, read about what the data offers. How do you then go about and solve it? So they look at someone who can solve the problem, not someone who can fastly solve it. Or I know binary search, I know the algorithm, this and this. Yes, we need to know that, but don't tell me about what you know, because the problem as a judge, I know those things. But how uniquely can you solve those things? And that's what difference between and then a hackathon winner and someone who just wanna be there and take the money.
Okay, thanks for that. Yeah, I think that's it from my side. I don't know if anyone else has any questions before we close. Just about 5 minutes, please.
I don't think anyone has questions.
Okay, that's fine. Okay, thank you for joining us, guys. And thank you so much to your HackerRank team as well for joining us and taking us through that. Like on my side, it was really fun as well and really welcomed. So I just want to send a message of encouragement to everyone as well to just hop on and get engaged with the platform. In the chat box, you'll see the link to accessing their team as well and getting in touch with their team. So yeah, guys, we're just looking forward to growing together and growing with technology. Yeah. So yeah, that's it from my side. Cheers and have a lovely evening.